Hello and welcome to another video from sickmaths.co.uk, where you can find the entire GCSE and A-level on video, all for free. Check it out. There are also some amazing revision guides, very cheap ones that blah blah blah, it's amazing stuff. Now, this video is about factorizing and solving quadratic equations. So let's talk about the title first of all. What's a quadratic equation? Well, it's an equation, i.e. something with an equals, and quadratic means it's got something squared in, like x squared. It's usually x squared, but it can be a squared and other letters, b squared as well, y squared. What does factorizing mean? Factorizing is the opposite of multiplying. So if I was multiplying this out, you would get that. If I'm factorizing, it gets you back to there. From here to there is factorizing, from there to there is multiplying brackets. So it's sort of the opposite. But what does factorizing actually mean? Factor means to find what is a factor of something. So factorizing means finding the common factor between all of these and taking it out to one side. So 3x divides into this, this and this. All of them divide by 3, 6, 9 and 12, and the x squared, x and xy all divide by x. They've all got x as a common factor. Okay, so that's why it's called factorizing, but practically it's like the opposite of multiplying. Okay, and so I've split it into two parts. I've got factorizing and solving. Okay, now I'm not simply solving, but I'm factorizing and solving when I'm doing the solving thing. I'll show you that in a second. Anyway, let's get on with factorizing. I've sort of told you about the factorizing bit already on this side, haven't I? When I'm factorizing this, I'm looking for a common factor between all three. So 3 is common between the numbers bit, so 6, 9 and 12, and x, okay, is common between the letters bit, the x squared, the x, and the xy. By the way, I said 6, 9 and 12. I should have said 3 is common between 6 minus 9 and 12, right? 3 goes into minus 9 as well. Anyways, minor detail. Anyway, so once I've realized that 3x is my common factor, I put it on one side, put a bracket, and I say 3x times what will make 6x squared? Well, 3x times 2x will make 6x squared. I'm not going to really tell you how to multiply brackets again, but very briefly, 3 times 2 is 6, x times x is x squared, so you get 6x squared. 3x times what will give you minus 9x. Just simply 3x times minus 3, which I've written there. So 3x times minus 3 gives you minus 9x, and 3x times 4y gives you 12xy. Now, if you didn't understand that, that means you don't really understand how to multiply brackets. Okay, so go to the multiplying brackets video and understand that first. Now, that's one way of factorizing, but I'm going to show you three ways basically. This is just copying that. Number 4 is copying the technique in number 3. But anyway, so that's the fast and easy way, the standard way. But you can't apply it to a situation like this. This is what we call a trinomial. It's a quadratic. It's got quadratic. It's not an equation yet because it doesn't have an equals, but it's a quadratic because it's got a squared in it. Okay, but it does not have really anything in the three things do not have anything in common. Okay, the numbers have got no common factor, 2, minus 11 and 5, and the letters don't have something in common. I mean, well, the 3 bits don't have a common letter because that doesn't even have a letter at all. Okay, so you have to apply another technique. Okay, and this is a very common question, so you need to get used to this. First of all, you write out your thing with the x squared bit first, or the squarey bit first. So it could be y squared instead, and then your linear bit, where it's just not squared at all, it's just got the letter with number, and you got the number at the end. And what you do is you take the beginning and end number, so in this case 2 and 5, which gives you 2 times 5, which is 10, and it gives you one target. Multiply target is 10, and the middle number, minus 11, is your other target. And what do you do with these targets? Very straightforwardly, you just say, give me numbers that times to make 10. 1 times 10 makes 10. Okay, minus 1 times minus 10 also makes 10, 2 times 5 makes 10, and minus 2 times minus 5 makes 10. Now, which of these pairs of numbers add to make minus 11? Well, minus 1 and minus 10 add to make minus 11, because minus 1 plus minus 10 makes minus 11. So that's the one I need. I tick that for myself, just to remind myself which one's the right one. And what do I do with it? Well, that minus 11x is going to become minus 10x plus minus minus 1x plus minus 10x. Although it's the same thing, I've written a different order yet, so I don't want you to get confused. So that minus 1 becomes minus 1x. That minus 10 becomes minus 10x. Okay, so now you've got this has turned into this. It's equal to it, doesn't it? Because that bit is the same as that, really, just split up. Then I split it into half, and I factorized this side just like I did over here. What's common between them? Well, no number is common, because that doesn't have a number. Well, it's got a 1 minus 1, but it's not common, is it, to the 2? So only x is common. So x is common to both bits. I put it to one side, put a bracket. X times what makes 2x squared? X times 2x. X times what makes minus x? X times minus 1. So I've got the stuff in my brackets. There's only 2 things there, so there should be only 2 things in the bracket. Over here, there are 3 things, so there should be 3 things in the bracket. Anyway, then I go and factorize this half. Can you see the dotted line? Yep. Okay, so this is that half. The dotted line is splitting the 2 halves. And it comes back together in a second. So you got minus 10x plus 5. What's common between those two? Well, 5 goes into both of them, and that's it. So basically, I'm going to write minus 5. And why do I put minus 5? Well, there's a very nice trick to make this easy for you. If I got 2x minus 1 as a bracket here, then I should have 2x minus 1 there. So what I actually did, instead of just factorizing, I said I'm going to put the bracket first, and I'm going to say, what times 2x gives you minus 10x. It's sort of gone the other way. I wrote the bracket first before I put the factor. Yeah. So I said 2x times what makes minus 10x is minus 5. Otherwise, I would have just put 5 and then minus 5 there, isn't it? No, I would have put 5 and 1 there, so that wouldn't help, because this bracket would be different to that. Okay, so it's a very good idea to put this bracket and then put the number outside, so that it multiplies to make this stuff here, because minus 5 times minus 1 makes 5 as well. Anyway, and to finish off, you put the 2x minus 1, this repeated bracket in the front, okay, and I put these 2 bits together over here. Now, I like to explain things. I just don't like you to say, oh, you just do it. Okay, how did I get from there to there? You can physically see that I put this bracket there, and these 2 came together to make this bracket. But why should that happen? Well, if I've got, say, 10 times this, 2x minus 1, and 2 times this, 2x minus 1 that is, okay, altogether I've got 12 times 2x minus 1. But instead, what I've got is x times that and minus 5 times that. So altogether, how many 2x minus 1s have I got? I've got x and minus 5 times 2x minus 1. And that's another way of writing this. X minus 5 times 2x minus 1. If that was a number, I would have put them together and then times it by that. But that's not a straightforward number. I don't know what number that is, so I just put it together like that in a bracket and times it by that, and my job's done. Now, let's move on to this another type of factorizing. You got a squared minus b squared always factorizes to this stuff here. If you got something squared minus something squared, it will factorize to something minus something times something plus something, and that something has to be the same as that, and that something has to be the same as that is too. And here's a quick example of how that works. I've got 4x squared minus 25. That is actually the same as 2x all squared minus 5 squared. So it's a bit like this. Something squared minus something squared. Something squared minus something squared. Okay, now I know it's that pattern. I know it's going to factorize like this pattern over here it is, yeah? So you got 2x over there, and you got minus 5 and plus 5 there, just like you got minus b and plus b there. So this goes there and there, basically, but one's got a minus, one's got a plus. In fact, if you wanted to, you could have put plus there and then a minus there instead. So it doesn't matter if you have it the other way around, because they're just multiplying each other. You could just reverse the order easily. Now let's get to solving.
This is not much more than this actually. First of all, this one doesn't really need any special technique. You got 2x squared is 18, therefore 1x squared is going to be 9, and then if you square root 9, you will get x obviously. And what's the square root of 9? It's 3 and minus 3. I hope you know that when you square root a number, you always get two answers that are equal and opposite. Because if you, let's quickly check that if that's true, 3 squared is 9, and if you do minus 3 squared, that gives you 9 as well. So they both are the square root of 9. Anyway, finally, let's actually use this technique here. You got 2x squared minus 11x plus 5 equals 0. So you got the same stuff as that, but it equals 0. Now earlier on we knew that can turn into that. That factorizes to this. 2x minus 1, x minus 5. So if that is equal to 0, so is that equal to 0. Okay? Now if you have two things that times together to make 0, that means one of them must be 0. Now when I say two things and multiply, what's happening here is you've got this whole bracket, okay, is one number really, if you think about it. If we knew what x was, we would times it by 2, take away 1, and we get a single number, right, inside that bracket. And the same over here in that bracket. And there's a secret times between the two brackets, because this is actually saying this bracket times this bracket. Now, so that means you're basically saying two numbers timesing together to make 0. That means one of them must be 0. Think of two numbers, go on. Let's say 3 and 0, yeah? 3 times 0 makes 0. Something times 0 must be 0. 0 times something must be 0. That's the only way. One of these brackets must be 0. So you can either say 2x minus 1 is 0, which if you try to solve that will simply tell you that x equals half. You should know how to solve simple equations like that. Move the minus 1 to the other side, take the 2 to the other side, you got 1 over 2. And the same sort of thing over here. If x minus 5 is 0, then x equals 5. Now we said one of them must be 0, but actually you can say both of them are 0 for different values of x. So basically, you solved this quadratic equation, and notice that we always make it equal to 0 to begin with. That's another thing. Okay, you factorize it, and then you solve each half, and blah blah blah, and you solved it. Thank you very much for listening.